Hello everyone, it's my fifth lecture and here we will discuss about the logical instruction. In the previous lectures we discussed about the data transfer instruction and arithmetic instruction and examples and programming based on these instructions. So the logical instruction, these instructions performs logical operations on data stored in registers, memory and the status flag. If we tell about the registers, registers means A register, B register, C, D, E, H, L. If we talk about memory, memory means the location of HL pair, and the status flag, that means the status of the flag register. All are 8-bit. The logical operations are in 8085 microprocessor. That is the AND operation, OR operation, XOR operation, rotate, compare and complement. And there are some few syntaxes or words we have to know about the meaning of these. PSW, we generally used PSW in next slides. So the full form of PSW is program status word. Dash, that is a flag unaffected, and a stick star, that means the flags are affected here. 0 means reset, 1 means set, S stand for signed flag, which is bit number D7. 0 means 0 flag, it is bit number D6. AC means auxiliary flag, it is bit number D4. P stand for parity flag, it is bit number 2. And CY carry flag, it is bit 0. So it is all about the some flag or PSW. So first we discussed about the AND, OR and XOR. Any 8-bit data or the contents of the register or memory location can logically have AND operation, OR operation, XOR operation with the content of the accumulator. And we discussed earlierly, and the result is stored in accumulator. Why in accumulator? As we discussed in the previous lectures, the accumulator is a part of the ALU unit, means arithmetical logical unit. So the one number should be in accumulator and the other number may be in any of the registers, and the final result after the AND operation, OR operation or XOR operation, the result will store in accumulator. Rotate instruction means the content of accumulator rotate or shifted one bit either left side or right side according to the instruction. We will discuss this instruction in next slides. Compare instruction, it's a very important instruction. Any 8-bit data or content of the register or memory location can be compares for equality, greater than or less than with the content of accumulator. The result is reflected in status flag. It's a very important point. If we are going to compare any register with accumulator, then there is no change in any register, only the flags are affected only. And if we are comparing anything, then there is only three options: either we are equal, or we are greater, or we are less than. There's only three options, and according to their three options, the flag status are changed. Complement, that means the content of accumulator can be complemented, means if it is 0, then it will become 1, and if it is 1, then it will become 0. It is the meaning of complement. So the first instruction and logical instruction is compare. So opcode is CMP and operand is R or M. R means any one of the register. It is A, B, C, D, E, H, L or memory. So what is the meaning of this instruction? CMP means compare. It compares accumulator with any one of the given register. So the content of the operand register or memory are compared with the content of the accumulator. Both the content are preserved, means there is no change in accumulator or any other registers. Only the data is compared. There is no change in the result or any register. The result of comparison is shown by the setting the flag of the PSW, that means program status word. That means only the flags are affected only after execution of this instruction. There is no change in any register or data. Like if we are comparing, let's suppose we used instruction CMP compare B. So compare B means A compared with B. So what is the meaning of A compared with B? Means either A is less than B, either A is equal to B, or either A is greater than B. There is only three options. There is only three options. So if first option, if A is less than B, if A is less than B, that means the number of B is greater than the number of A. So meaning of comparing B, just let's suppose the content is A have a 5 and the B has a 6. So 5 minus 6, we subtract 5 minus 6. So there is a borrow. Borrow means there is a carry flag. So in this instruction, if the content of A is less than B, then the carry flag is set. In this case, only carry flag is set. There is no change in A and B or any other register. It is the first case. Second case, if A is equal to B. In that case, if A is equal to B, then both the number are same. If both the number are same, in that case, if the A is equal to 5 and B is equal to also 5, then 5 minus 5 is 0. So in that case, the carry flag is reset, but there is a one other flag. If the result will 0, in that case the 0 flag is set. So in that case, especially in this case, the 0 flag is set. So very, very important. And if A is greater than B or any other register, in that case, if A is greater than B, that means if A have a 5 and B is a 4, in that case 5 minus 4, that case there is no carry. That means carry flag and zero flag are reset. Why reset? Because there is a 5 minus 4, there is some number. In that case, the zero flag is reset, and there is a number, and one number, first number is greater than the second number. That means there is carry flag is reset. So compare instruction. There is a very important, once again there is a very important, there will be no change in accumulator or any register. Only the status flags are affected after execution of this instruction, CMP. It is a 1 byte instruction. Next instruction, CPI. What CPI? I stand for immediate. As we previous lectures we studied about the ADI, SBI, ACI. I stand for immediate, where we required 8-bit data. So CPI compare with immediate with 8-bit data. So here the operand is not a register, the operand is a 8-bit data. So the accumulator is compared with the 8-bit data. So it is a 2-byte instruction, 1 byte for opcode and another byte for operand. So A and 8-bit data are compared and results affected, result not, the status flags affected according to the numbers. That means if accumulator is greater than the 8-bit data, in this case the carry flag and the zero flag is reset. If the accumulator is less than the 8-bit data, in that case carry flag is set, and if the accumulator is equal to the 8-bit data, in that case zero flag is set. It is similar to the previous case. Here only we know about the 8-bit data. As here we write CPI, the example, if A the data carry A is less than data, carry flag is reset, is set. If A is equal to the data, then the zero flag is set. If A greater than of the data, the carry and zero flag is reset. Now the next logical instruction, A and A. The full form of A and A and A, that means it is a logical AND. That is a logical AND. AND means and with accumulator. So here the opcode is A and the operand is R or memory. R means register. As we previously told, the R may be A, B, C, D, E, H, L, or means of memory. Memory means if the operand is memory location, its address is specified by the contents of HL pair. So in ANA, the content of the accumulator logically AND with content of the register or memory. The final result is placed in accumulator. The final result is placed in accumulator. The sign flag, zero flag and parity flag, there is only 3 flags. Sign flag, zero flag and parity flag are modified to reflect the result of the operation, and the carry is reset and the auxiliary carry is set. It is fixed. Only 3 flags are affected according to the data, and carry flag is reset and auxiliary carry is set, like ANA B or ANA M. Here we have example. Let's suppose in accumulator we have 87 and B we have 54. If we convert in the binary, so as we know, we can convert, right, like a 7, that means 0 1 1 1, that is a 7, 8 matlab 1 0 0 0, and 54 like 0 1 0 1 0 1 0 0 0, means if we write in first digit 8421, like 8421, so in 4 here is a 4, then we can write here 1, so it become 4, and 5 8 4, 4 plus 1 is 5, so it will become 54. So 87 and 54. Now if we write instruction A and AB, A and AB, so logically AND with B register. So the accumulator have 87 and B have a 54. So after execution of this instruction, A 1 0 0 0 0 0 1 1 1 1 and B 0 1 0 1 0 1 0 0. The meaning of AND, logically AND, or we can say the truth table of logically AND, if both the inputs are high, high means 1 or set, then the output will be high or set, otherwise output will be 0. We already know about the truth table of the AND operation. What is the meaning of the AND operation? Once again I repeat, if both the inputs are high or set or 1, then output will be high or set or 1, otherwise output will also low, or we can say 0. So if we have a 1 and 1, then output will be 1. So in the first case it is a 1 into 0, it will be 0. In second 1 0, it is a 0, 1 1, it is a 1. As we already told you, if both the inputs are high, then the output will be high. There is 0 0 0 0 1 0 0 0 0. So the result will be 0 4 H. So it is an example. If we use the logical AND for this instruction, the output will be 0 4 H. Next instruction, it is A and I. That means, what is the meaning of I? It is the immediate, as we previously told. The meaning of I is immediate. That means logical AND with 8-bit data. So it is a 2-byte instruction. That means the content of the accumulator are logically AND with the 8-bit data. The result placed in accumulator, and S, Z and P are modified, and CY are reset, and is auxiliary carry is set. Same as a previous instruction. There is only difference is the previous instruction is a 1 byte, then means we don't know about the data. Here it is a 2-byte instruction and we know about the operand, that means 8-bit data. Next instruction, it is the OR logically OR. So ORA, R or M. So logically OR with any register. So logically OR or register or memory with accumulator. In this, the content of the accumulator are logically OR with the content of the register of the memory. The result is placed in accumulator. If the operand is a memory location, its address is specified by the content of HL pair, and the sign flag, zero flag and parity flag are modified to reflect the result. Here important thing is carry flag and auxiliary flag both are reset, like ORAP. So we take a example, same number as we previous taken. So if A have 87 and B is a 54, so the 87 can written in this format as a binary and 54 in this format. So we know about the truth table of OR. What is the truth table of OR? If both the inputs are low or reset or 0, then the output will be 0 or low or reset. Otherwise, output will always high. It is a truth table of OR gate. So in this case, 1 0 it is 1, 1 0 is 1, 1 1 is 1, 0 0 0, 1 0 1 is 1, 0 0 0, 0 1 1, 0 1 0 1. So if it is a result. So here if we write in a hexadecimal number, here 8421. So 8 plus 4 12, 12 or 1 13. So the 13 is written as D and it is a 0. 8421. So 4 plus 2 plus 1 is a 7. So D7. That is the result is D7. ORI, as we previously discussed about the I stand for the immediate. So it is a 2-byte instruction. Here opcode is ORI and operand is a 8-bit data. So in this case we have a 8-bit data for the OR operation, and same things, all the these things are same as previous instruction. Next is XOR, XRA. So logically XOR register or memory with the accumulator. So in this case, the content of the accumulator are XORed with the content of the register or memory. The result is as usual placed in accumulator, and sign flag, zero flag and parity flag are modified, and the carry flag and auxiliary flag are reset, like XRA P or XRA M. So we can take an example. We have a same number. If we have A is 87, B is 54. Now if the XRA B, so after execution of this instruction, what happened? So first we have to know about the truth table of XRA operation. So if we have a two number A and B, so according to the XRA table, it is, if we have a two number, so the truth table of XOR A B bar plus A bar B, it is a output of a XOR table. So what is the meaning of this? So we can say the simple word, if both the inputs are high or if both the inputs are low, if both the inputs are high or both the inputs are low, then output will always 0 or low. If both the inputs are different, then the output always high or 1. I repeat once again, if both the inputs are same, or we can say high or low, then output always low or 0. If both the inputs are different, then the output will be different. Output will be 1. So if we have a 1 0, so the output is 1, 1 0 1, 1 1 0, 0 0 0, 0 1 1, 0 0 0, 0 1 1, 1 0 1. So if we write in hexadecimal, it is a 1 1 0 1. That means 8 4 8. Sorry friends, here the answer is right, but A is not B3. If we write in here 8 plus 4 XRAB, means if both the inputs are same, then the output will be low. So here 0 0 0, 0 0 0, and remainings are 1. So here first case it is 1 1 0 0 1 0 1 1. So 8 plus 4 12 plus 13. 13 means D3, not B3. It should be D3. So if we write, it should be D3. Next is XRI, means XOR immediate with accumulator. So here opcode is XRI and operand is 8-bit data. So it is a 2-byte instruction, and the truth table and all things are similar as we discussed previously. So it is all about the 5th lecture. Students, there is some questions for you. Write a program for a mask of MSB, first question, and write a program for a mask of LSB, second question. We will discuss in this question in next lectures or in next discussion class. Thank you.